After years of speculation, mystery, and countless theories, the James Webb Space Telescope has delivered images that may reshape our understanding of one of the most enigmatic stars in the sky, Betelgeuse. For decades, both scientists and casual stargazers have been fascinated by this colossal red supergiant, one of the largest and brightest stars visible to the naked eye. Situated in the shoulder of the Orion constellation, Betelgeuse has long occupied a place of cultural, astronomical, and scientific intrigue. But in recent years, the fascination has grown into something deeper and more urgent. When the star began dimming unexpectedly, astronomers and the public alike speculated that it might be nearing the end of its life, preparing to explode in a spectacular supernova that would briefly outshine the sun itself and alter our night sky for generations. Such an event would be visible even during the day and would mark one of the most extraordinary cosmic spectacles humanity has ever witnessed. Yet, as time passed and no explosion came, the mystery of Betelgeuse only deepened. For years, telescopes around the globe monitored its fluctuating brightness. The star dimmed, then brightened, only to dim again in a seemingly erratic pattern that baffled even the most experienced astrophysicists. For a star that shines more than 100,000 times brighter than our sun, such sudden changes were not only unusual, they were alarming. Was this the long-anticipated sign that Betelgeuse was collapsing? Or was something else entirely happening within its fiery depths? The lack of clarity left astronomers eager for more advanced tools that could pierce through the veil of dust and gas surrounding the star and reveal its true condition. The moment of clarity finally arrived when the James Webb Space Telescope, humanity's most ambitious and powerful observatory, turned its massive golden mirror toward Betelgeuse. The James Webb, or JWST, was designed not only to peer across billions of light-years to study the earliest galaxies formed after the Big Bang, but also to examine nearby celestial objects with unmatched precision. Its 6.5 m segmented, gold-coated mirror paired with highly sensitive infrared instruments allowed scientists to see details invisible to previous generations of telescopes. When Webb's instruments focused on Betelgeuse, astronomers were not merely hoping for answers. They were prepared for a revelation. What they saw exceeded even their boldest expectations. The images revealed that Betelgeuse was not quietly slipping into death's embrace, but rather erupting in violent and turbulent fits of activity. Its surface, far from being calm and predictable, was alive with immense hotspots and vast, glowing regions that shifted rapidly across its structure. What had appeared to be a star losing its light was instead a star casting off massive portions of its outer layers in colossal stellar mass ejections events. So dramatic they dwarfed anything ever observed from a star of this type. These eruptions hurled gas and dust into the surrounding space, forming vast and irregular clouds that obscured Betelgeuse's light when viewed from Earth. What astronomers once interpreted as the dying flickers of a failing star turned out to be the shadows of its own expelled material drifting across our line of sight. This revelation radically altered the narrative surrounding Betelgeuse. It was not simply fading. It was erupting, shedding its atmosphere in violent bursts that reshaped its outer layers within weeks. In astronomical terms, this is nearly instantaneous. The discovery left scientists arock. It suggested that the late stages of a massive star's life are not neat, predictable processes, but rather chaotic and volatile convulsions that defy simple modeling. The implications are profound. For decades, astrophysicists believed that the life cycle of a massive star followed a relatively linear path, a long stable phase of nuclear fusion followed by a slow decline into instability, culminating in a dramatic supernova explosion. But Betelgeuse behavior calls this tidy framework into question. Instead of a graceful march toward collapse, it appears that stars may enter an extended phase of instability, characterized by massive eruptions, fluctuating brightness, and structural upheaval. These revelations suggest that the twilight years of a star's life may be far more complex than previously thought, involving chaotic episodes that could span decades, centuries, or even longer. Within the scientific community, debate has ignited. Some argue that Betelgeuse's dramatic instability signals that it truly is nearing the end, perhaps only decades away from exploding. Others suggest that it could remain in this turbulent state for centuries before finally succumbing. Either way, Betelgeuse has already proven itself to be a laboratory of cosmic change, offering astronomers a chance to witness stellar processes that were once only theorized. It is an unprecedented opportunity to observe in real time the violent transformations of a star nearing the end of its life cycle. Yet, beyond the scientific intrigue, there is a philosophical dimension to this discovery. Stars like Betelgeuse are not merely distant points of light in the sky. They are the cosmic forges that create the very elements of life. When a star of such immense size eventually explodes, it scatters heavy elements, iron, oxygen, carbon into space. These elements become the building blocks of planets, atmospheres, and living beings. Every breath we take carries atoms born in the heart of a long-dead star. In this way, watching Betelgeuse struggle, erupt, and convulse is not only a scientific endeavor, but also a reminder of our own origins. We are quite literally the descendants of stars. The James Webb Space Telescope has made this connection more immediate and tangible than ever before. By piercing through the thick veil of dust that obscured Betelgeuse, Webb has shown us the star's true face: chaotic, unstable, and magnificent. Technology represents decades of human ingenuity and cooperation, the product of thousands of scientists, engineers, and visionaries working across nations to achieve a common goal. The telescope itself is a marvel, an observatory the size of a tennis court folded like origami to fit inside a rocket and then flawlessly deployed 1,000,000 miles from Earth. Its golden mirror and infrared sensitivity allow it to capture the faintest whispers of light, whether from the first galaxies or from a neighboring supergiant star. The images of Betelgeuse it has delivered are not merely data points. They are windows into cosmic truth. They challenge us to rethink what we know about the universe and remind us of its capacity for surprise. They also reveal the limitations of our earlier assumptions. Previously, scientists believed that red supergiants dimmed and brightened in predictable pulses, regulated by internal processes of fusion and convection. But Betelgeuse has proven otherwise. Its rhythms are irregular, governed not by gentle cycles, but by violent upheavals and unpredictable outbursts. This insight will force a re-evaluation of how we understand the evolution of massive stars, not only in our galaxy but in countless others scattered across the cosmos. As Webb continues to study Betelgeuse, we are not only watching the potential end of a star, but also learning about the processes that shape the universe itself. The material expelled in these eruptions will one day drift into interstellar space, mix with other remnants, and perhaps form new stars and planets. In this sense, Betelgeuse's death is not an ending, but a transformation, a contribution to the ongoing cycle of cosmic creation and renewal. The universe is a place of destruction and rebirth, and we are part of that endless story. Even our own sun, though far smaller and less dramatic than Betelgeuse, will one day undergo its own transformation. It will not explode in a supernova, but it will shed its outer layers and form a planetary nebula, returning its material to the galaxy and seeding the future with the elements of life. In watching Betelgeuse, we are watching not just the fate of a distant star, but also the echoes of our own eventual destiny. Every discovery made by Webb brings us closer to understanding these cosmic truths, but it also deepens our appreciation for the beauty and complexity of the universe. Betelgeuse's eruptions remind us that the cosmos is not static, but alive, dynamic, and ever-changing. The night sky is not a fixed tapestry, but a living record of cosmic evolution in which we are participants rather than mere observers. In this sense, the James Webb Space Telescope is more than a scientific instrument. It is a bridge between human curiosity and the vastness of the universe. It is a time machine, offering us glimpses into both the distant past and the unfolding future. Each image it sends back invites us to marvel, to question, and to reflect on our place in the grand story of existence. The revelations about Betelgeuse are only the beginning. The universe holds countless more mysteries waiting to be uncovered. With Webb, we are poised to witness them, to expand our knowledge, and to deepen our connection to the cosmos. Betelgeuse chaotic behavior may rewrite our textbooks and challenge our models, but it also offers something greater: perspective. It reminds us that the universe is not a distant abstraction, but the very fabric of our being. We are starborn, woven from the remnants of cosmic giants and destined to return to that cycle when our time comes. Watching Betelgeuse convulse and erupt is therefore not just science. It is a meditation on creation, destruction, and the eternal cycle of life in the universe. The story of Betelgeuse as revealed through the James Webb Space Telescope is not merely the tale of a single star's instability. It is a chapter in the larger saga of how humanity comes to terms with its cosmic surroundings. For centuries, cultures around the world looked up at Orion's shoulder and were myths about the reddish star burning brightly in the winter sky. Ancient civilizations had no way of knowing its size, distance, or nature, but they recognized its power, embedding Betelgeuse in their stories of gods, hunters, and heroes. Now, thousands of years later, we return to that same star with instruments of unimaginable sophistication, capable of dissecting its surface and measuring its tremors across the void. The continuity between ancient wonder and modern science is striking. We are still telling stories about Betelgeuse, only now, with data, models, and high-resolution imagery that bridge imagination with reality. One of the most astonishing aspects of the Webb revelations is the sheer scale of the processes taking place. Betelgeuse is about 1,400 times the diameter of our Sun. If it were placed at the center of our solar system, its surface would extend past the orbit of Jupiter. The eruptions documented by Webb are not minor flares. They are cataclysmic events that could engulf entire planetary systems if they occurred nearby. When Betelgeuse sheds a portion of its outer layers, it releases more mass than our Sun produces in centuries of solar winds. The idea that such massive chaotic forces can be observed in real time is extraordinary. For astronomers, it is like watching a natural disaster on a cosmic scale, only slowed down by the vastness of space and time. Yet, despite its distance about 650 light-years from Earth, Betelgeuse feels close, almost intimate. Its bright glow is one of the most recognizable features of the night sky, guiding countless eyes toward Orion's familiar outline. The thought that we are watching a neighbor star arrive in its death throes adds a human dimension to the science. This is not some anonymous galaxy billions of light-years away, barely perceptible in the deep field of a telescope. This is a nearby giant, visible to anyone who steps outside on a clear night, now revealing its secrets through technology we built with our own hands. Webb's observations also carry profound implications for our understanding of supernovae. Until now, most of what we knew about these explosive endings came from either distant supernova remnants, ghostly shells of gas expanding into the void, or from rare real-time events in other galaxies, often millions of light-years away. Betelgeuse gives us a chance to study the precursor stages up close in detail never before possible. By monitoring its cycles of mass ejection and surface turbulence, astronomers can piece together the puzzle of how a massive star transitions from instability to collapse. This knowledge could in turn allow us to predict when and how stars explode, offering insights into one of the universe's most important processes for recycling matter and seeding galaxies with the elements of life. Of course, there is also the tantalizing possibility that Betelgeuse could explode within our lifetimes. While most experts caution that it may remain unstable for centuries, the unpredictability revealed by Webb leaves room for uncertainty. The thought of waking up one morning to find a second sun glowing in the sky, brighter than the full moon and visible in daylight, captures the imagination in a way few astronomical events can. Such a supernova would not harm Earth due to our safe distance, but it would leave an indelible mark on human culture. Writers, poets, scientists, and ordinary stargazers alike would witness a cosmic spectacle that no generation has seen before. It would be a reminder that the universe is not static, that stars live and die before our eyes, and that we are participants in a cosmic drama of staggering proportions. But even if Betelgeuse does not explode soon, what Webb has already uncovered is groundbreaking. The detection of asymmetric plumes, hotspots, and chaotic surface shifts suggests that massive stars may not follow the neat evolutionary paths long assumed. Each star may have its own rhythm of convulsions dictated by internal dynamics we are only beginning to understand. This realization forces astrophysicists to revisit their models, not just for Betelgeuse but for red super giants across the cosmos. If these stars are more chaotic than expected, then our predictions about their lifespans, explosions, and contributions to galactic chemistry may need significant revision. In this sense, Betelgeuse has become a kind of ambassador, teaching us lessons that ripple outward to affect our entire view of stellar evolution. Beyond the science, there is a deeply human quality to this discovery. The James Webb Space Telescope is not simply a machine. It is a vessel of human ambition, the culmination of decades of perseverance, setbacks, and breakthroughs. Thousands of people devoted their lives to making it a reality.